Hey guys, today we're going to start chapter 3 with actually a little pre-chapter section, 3.0, because this chapter is all about solving polynomials of many different degrees. So before we can get into any of the specific things for chapter 3, I want to take a day just to review factoring, because that's going to be hugely important that we can factor things accurately, precisely, and with some efficiency, so it doesn't take too long to do it. So that's why I wanted to take today and just go through all the different things, all the different factoring tools we should know going into Algebra 2, to just reestablish those so that once we get into them and have to utilize them, they're not totally brand new to us or we totally forgot how to do them. So, 3.0, Factoring Polynomials. Before we can do that, let's go ahead and actually start even further back and just take a look at our different multiplication methods. So, for a polynomial, we know a polynomial could be, here the expression of the form ax squared plus bx plus c. That's really a quadratic in that form, but a polynomial could be any number of terms, but here specifically most of the factoring that we'll be doing is for a quadratic, not necessarily just a polynomial or any particular polynomial. But I digress. A little sidetrack, just noticed that was still up there as well. Anyway, so we've got a couple of different multiplication methods that'll help us kind of refresh ourselves to make it easier to factor. So we do have the old school distribution method, which we probably dubbed, or you're used to seeing it called FOIL, double distribution, where all I'm doing is multiplying my first parenthesis into the second parenthesis. So FOIL means first times first, outsides, insides, and lasts. So FOIL, firsts, outsides, insides, lasts. That just tells me all the different multiplications that have to happen in order to simplify these two together. So x times 2x is 2x squared. Outsides would be x times negative 1, which would be a negative x. My insides is 3 times 2x, which is a positive 6x. And then my lasts, 3 times negative 1, would be negative 3. From here, I just need to make sure I combine my like terms. So in this case, my negative x and my positive 6x are like terms. So 2x squared plus 5x minus 3 is my final simplification. That's my multiplication. That's my product. Our other method for this was box multiplication. So this kind of like Punnett squares in biology, if you did that with some genetics stuff. For these, for multiplication, this is more of a visual, kind of a spatial thing rather than an algebraic method. So for these, my 2x plus 3 and my x minus 2 are my two parentheses. I'm just going to make each of my two dimensions, the top of my box and the side of my box, those terms. So my first parenthesis is 2x plus 3, so 2x is one column, 3 is the other column. My other parenthesis is x minus 2, so x is my top row, negative 2 is my bottom row. And then where these intersect is what you get, is where you get your product from. So this top left box, 2x times x is a 2x squared. 3 times x would be 3x. 2x times negative 2 is a negative 4x. And then 3 times negative 2 is a negative 6. I still have to collect up my like terms. So here, my 3x and my negative 4x are my only two like terms. So in total, I end up with 2x squared minus x minus 6 for this particular product. So that is our multiplication methods. Getting into our first factoring method, our first one that we always check for is a GCF. Remember, GCF stands for greatest common factor, meaning we're looking for something that all of the terms in my polynomial have in common. If I have something that was in common, I'm going to undistribute those. If you think of it in terms of distribution or multiplication, I'm just taking each of those out. So in this case, for example, number 3, they have a 3 in common. 3x squared plus 3 are both multiples of 3. So if I take that 3 away, what I would be left with, 3x squared divided by 3 is just x squared. Positive 3 divided by 3 is just 1. So 3 times x squared plus 1 is where that would factor out into, or what that would factor out into. For example number 4, negative 2x squared minus 4x. They both are multiples of 2. They're both even numbers, so we could definitely take that 2 out. They're both also negative, so I could call my GCF a negative 2. Just, we want to include as much as possible. The other thing they have in common is my x. Both of them are divisible by x. They both have an x involved, so negative 2x would be my GCF. Now, if I factor that out of my two terms, taking the negative 2 and one of the x's away would just leave me with x for that first term. And then dividing by negative 2x would leave me with just a positive 2. So negative 2x, parenthesis, x plus 2. Last and certainly not least, this one a little bit funky, but it really helps set up something we're going to do on the next page, the back side. 3 parenthesis x minus 1 plus x parenthesis x minus 1. In this one, a little bit strange again, but I still have two terms, right? There's a single plus separating my two terms. And in both of these, they have an x minus 1 in common. So even though it's not a usual thing that we see, we can actually factor out a parenthesis from each of those terms. And if I do that, that leaves me with just 3 for my first term and x for the second one. So x minus 1 times 3 plus x would be the final simplification. Moving right along. So what does it mean to factor polynomials? Well, again, we want to first take out something in common. That's going to be our first step. And then beyond that, to factor it out, we want to basically figure out what we'd have to multiply together in order to get the original polynomial. So we want to multiply factors together to get the polynomial. So we've got a bunch of different methods on how we can figure out what those factors are, what those things are that we have to multiply together. And it kind of varies, which one we use varies based on how our function or how our polynomial is presented to us. We could do regular old school factoring methods where if our polynomial is just x squared, then we can look at what adds up to my b value but multiplies to get my c value, which I'll do one of those a little bit later. If we're stuck on something, kind of the more procedural way of doing this, if you guys remember from Algebra 1, is Xbox factoring, which is basically that box multiplication method working backwards. We're just working in reverse. We start with the stuff that's inside my box, and we need to find what the top and the bottom are of that box. So to do Xbox factoring, again, we have, so for this example, I'll try and space this out so I keep all of my steps here without moving around too much. So for our Xbox factoring method, our first step is going to be putting our first and last terms in the opposite corners, which really, these steps, you can go, some of them a little out of order. The way that I do it is not necessarily how I wrote it up here, because this is just kind of stuff you can do right away. Every single time you can do Xbox factoring, you can start with this term. But really, it's kind of just setting up information that needs to go in the box, and then you could once you have all the information, then you could go to the box if you want to. If we follow these steps, just for the for the sake of the video, we can go ahead and do that. So step 1, put our first and last terms in opposite corners. So in my box, my first term is 3x squared. My last term is negative 8. And they are always in those particular corners. My first term is always the top left box. My last term is always my bottom right box. So then for my other two corners, I need to use my x. So in the x of Xbox factoring comes from figuring out what those two parts are. So over here, I'm going to go ahead and just draw an x. And it really doesn't matter where you put this. But our next step, we're going to write up top. Let me try and get a little bit straighter lines. Sure. So up top, and so in our x of Xbox factoring, up here it's always a times c, and then our middle term, our middle term, b, is always the bottom. So a is the coefficient on the first term, b is the coefficient on the second term, c is the coefficient on the last one. So if you look back up to the very top of the notes, it says polynomial in the form of ax squared plus bx plus c. That a, b, and c is what we're talking about here. So in this one in particular, a times c, our first term times our last term, would be 3 times negative 8, which is a negative 24. And then our middle term is just 2. So steps 2 and 3 here are what we're doing next with that information. So step 2, we're going to find factors of a times c, and we're trying to figure out which of those factors, what things multiply together, in this case to be negative 24, that add up to b. I'm going to space that out a little bit better. Add up to b. So this is a part of the process where it could be really obvious to you what they are. It could be something that we struggle with a little bit. I always like to try and make a list of my different factors, things that multiply together to give me negative 24. So I have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So that little scratch work up there, those are all the different combinations of numbers that multiply together to give me 24. In this case, since it's a negative 24, one of those will be positive, one of those will be negative. So if I'm trying to figure out which one of those pairs add up to positive 2, if one of them is positive and one of them negative, that means they're 2 units apart. That tells me, in this case, 4 and 6 is that combination that I'm looking for, because 4 and 6 are exactly 2 spaces apart. Now, because I have to multiply to get negative 24, one of them will have to be positive and one of them will have to be negative. In this case, since I want them to add up to a positive 2, I want my bigger one to be the positive number. So here, on the left and right side of my x are going to be negative 4 and negative 4 and positive 6. Because negative 4 times 6 is negative 24, but negative 4 plus 6 is positive 2. So that's getting us all the way through to step 3. Step 4 is you're going to put each of those numbers into the other 2 boxes of the square. And here I should put, amend this, put them in the boxes with the variable. Because this really is negative 4x and 6x. Not just negative 4 and positive 6, but it has to have the variable with it as well. It doesn't matter which one you put where, whether the negative 6 or the negative 4 goes in the bottom left or the top right. So that's just what we have. From here, you're just working backwards to figure out your left side and your top side. So the left and the top of my box. Now, to make this easier, I always start by just picking one of my rows or columns to try and find a GCF and put that on the outside of the box. So this could be, here I say block off the bottom row and then find the GCF and then put that on the outside of the box. But really, this really becomes just a puzzle. It becomes like a Sudoku type thing, where if you're good with numbers and you're able to figure things out, it kind of goes hand in hand. So here, you're either going to be looking at this top row, what do they have in common? The bottom row, what do they have in common? Or it could be, this left, ooh, that doesn't work with 2 blues. Let's do in green here. Or the left column and the right column, what do they have in common? I usually just start with either the top row or the left column, just because x and x squared are always going to have an x thing in common. I'm going to switch to red for this. So if I look at my top row, 3x squared and 6x, the GCF between those two, they both have a 3 in common and they both have x in common. Once you know that, then the rest of it becomes, what do I have to multiply by? So if I know 3x is this left label, 3x times something would have to give me 3x squared, which means this right here has to be x. 3x times 2 would have to give me was what I would need in order to get 6x. And then for either of the two bottoms, x times a negative 4 would give me negative 4x, or 2 times negative 4 would give me a negative 8. So that tells me that my factorization is x plus 2, that's my top label, times 3x minus 4. So that's our answer. That's our final factorization using Xbox factoring. Let's undo that a little bit. Yeah, cool. Awesome. Okay. Now, that's not always necessary. Here I say that you have to factor using the box method, but there are other ones that we have as well. If we look at something like number 1, where I'm just trying to factor this out, don't forget your old school method, kind of old school method, where if it's just an x squared, you're looking for what two numbers add up to my middle term but multiply to get my last term. So if I do just my old school 2 parenthesis factoring method, I know my 2 parentheses are going to have x and x, because x times x is the only thing that gives me x squared. So for those other 2 numbers here in my parenthesis, I'm trying to figure out what 2 numbers multiply together to give me 5, but add up to 6, which, at least for me, I'm hoping for most of you, is pretty clear to see that, nope, I say that with confidence and then write the wrong combination here. Nope. Goodness gracious. I'm not editing this out just because, mistakes happen, and that's okay. You guys need to see that. Yeah, 1 times 5 is 5, but 1 plus 5 is 6. What I was doing there, I kind of just switched it in my head if you guys didn't notice. 2 times 3 would be 6, but adds up to 5. But I have to be careful because it has to add up to the middle term, but multiply together to get my last term. So x plus 5 times x plus 1 would be how that would factor out. Okay, I'm going to bounce around a little bit. Let's go ahead and take a look at number 4, since it's still right here on my screen. For number 4, first thing I'm checking for is a GCF. There is not a GCF between 4 to negative 2 and negative 3, so I have to go to Xbox factoring. So for Xbox factoring, I'm going to go ahead and start with my x. My top comes from my first term times my last term, so 4 times negative 3 would be a negative 12, and then my bottom is just that middle term, so negative 2. So now I'm trying to figure out what 2 numbers multiply together to give me negative 12, but add up to negative 2. So I'm going to go ahead and just write down my combination of different factors to get negative 12. 1 times 12, 2 times 6, and 3 times 4 are only combinations. Right? So again, it's negative, so one's going to be positive, one's going to be negative. So really my list is negative 1, positive 12, negative 2, positive 6, negative 3, positive 4, and then also 1, negative 12, 2, negative 6, 3, negative 4. But none of these, if you look at it, this is 11, 4, 1, negative 11, negative 4, negative 1. None of those add up to a negative 2. So a little tricky one right off the bat. This one is actually not factorable. Because if you can't factor it using Xbox factoring, it's not factorable at all. If it's factorable, Xbox factoring will work. There's other methods where if you can't use those methods, it doesn't necessarily mean that it's not factorable. But if you can't even Xbox factor it, then there's no point in trying. All right, number 5. This is another one that I wanted to remind you of. This is another special case. Here we have only 2 terms, x squared minus 16. This is our difference of 2 squares. So in that one, if we had x plus, let's just say a, x minus a, that expanded out into x squared minus a squared. So if we start with something that is a difference of 2 squares, x squared minus a squared, then working backwards, we can simply conclude that this would be x minus 4 times x plus 4, because 4 squared is 16. pretty straightforward. Again, you also could do this the old school method way if you wanted to, where since we don't see an x term in here, you could call this a 0x, and then do x squared plus 0x plus 16, sorry, minus 16. Minus 16. And then you say, oh, well, okay, well, what multiplies together to give me negative 16 would adds up to 0, which of course is negative 4 and positive 4. All right. So 2 and 3, those ones are regular Xbox factoring methods. Let's just, I guess we'll do number 2 here real quick, just to, again, show you guys this method. So here, first times last, 9 times negative 2 is a negative 18. My middle term is a negative 3. So I'm trying to figure out what combination of numbers multiply together to give me negative 18, but add up to positive 3. So if I make my list real quick, I have 1 times 18, 2 times 9, 3 times 6. Those are my 3 different combinations. The pair that are 3 units apart are 3 and 6. So since I want it to add up to be a negative 3, I'm going to make it a negative 6 and a positive 3 for my two sides. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So then going to the box of my x box factoring, my first term, 9x squared. My last term, negative 2. The 2 other pieces that I just found were negative 6x and 3x. So then if I go to red, the top row is what I'm going to try and find the GCF of. They both have a 3 and an x in common. Since that's 3x, this also has to be 3x to multiply together to be 9x squared. This would have to be a positive 1 in order to get to 3x, which means this has to be a negative 2, because 3x times negative 2 would be negative 6x, or 1 times negative 2 is negative 2. So my answer here for number 2 would be 3x plus 1 times 3x minus 2. That would be my final factorization for number 2. I'm not going to do number 3 with you. You don't have to do number 3 if you don't want to. If you want some extra practice, go ahead and give it a shot. But we're going to move on. Our last factoring method, and this is one that we really didn't cover in depth in Algebra 1, but this is something that we will use here in Algebra 2, which is factor by grouping. Factor by grouping is the one method that we can actually use if we don't have 3 terms. I'm confusing myself with a different kind of grouping, factor by grouping method. This is really just a different way of writing Xbox factoring. If you want to, I was thinking before I was looking at this that this is a different factor by grouping, which we'll talk about in a later section what factor by grouping is. But this is basically kind of distribution backwards. If Xbox factoring is box multiplication backwards, grouping method is distributing backwards. But it's really the same method, it's just without the visual aspect of it, so I'm not a huge fan of it. I'll show this to everybody if this floats your boat and this makes you happy and this makes more sense in your brain, then go ahead and do that. But I'm always going to factor using Xbox factoring just because it's a more organized method of madness. So with this, if we're factoring out 3x squared plus 10x plus 8, our first step, we go straight to finding factors of a times c and figuring out which one of those factors adds up to b. Once we know what those are, we're going to take that 10x and split it into those two numbers. So in this case, I'm looking for factors of 3 times 8, which would be factors of 24. That's a times c. I'm looking for factors of those that add up to 10. So 20 factors of 24 would be 1 and 12, 1 and 24, 2 and 12, 4 and 6, 3 and 8. But 4 and 6 here is the one we want to go with because 4 times 6 is 24, but 4 plus 6 is positive 10. So we're going to split this up, this 3x squared plus 10x plus 8. We're going to actually split it up into 3x squared plus 4x plus 6x plus 8. So I'm taking that 10x and rewriting it as 6x and 4x, because 6 times 4 is 24, 6 plus 4 is 10. So now what I'm doing, you're writing it out. Here we go. Write it out in one expression. And then from here, we're going to group like terms and like terms. This should happen naturally the way it's already organized, where you should be able to take these first two terms and these second two terms and find a GCF between those two. So a GCF between each of those within the pair. If that doesn't happen, that means you did not find those two numbers correctly. Because from here on, this is what I'm talking about with what we call factor by grouping, where if we have 4 terms, we're going to try and find GCFs between pairs of them to do some factoring from there. So here, if I look at my first pairing, 3x squared plus 4x, they have an x in common. So x times 3x plus 4 is what I would be left with. My 6x plus 8 have a 2 in common, so positive 2. And here again, I'm left with 3x plus 4. So what I'm doing here for that step is actually step 5. I'm factoring out a GCF. And again, this is going to be from each group, each pairing. So that's what I did. Now this, if you notice, my parentheses are the same. That should happen. Again, if this doesn't happen, you've made a mistake somewhere. Take a look back up further in your problem and try and figure out where that happened. But now that I have that, just like we did on that GCF problem up above, whatever that was, example 3 or example 4, I now have these two parentheses in common between my two terms. So I can factor that out and get 3x plus 4 times x plus 2. And that would be my final answer. And that is that last step. Factor out the GCF again. And in this case, it's going to be here your parentheses. Okay. Again, I'm not going to go through every single one of these. Every single one of these examples. I can, hit some highlights again if you wanted to, but 5 and 9, again, are regular old school factoring methods or difference two squares. So again, here, just to kind of reiterate these. For number 5, I'm looking for two things that multiply together to give me 12, but add up to a positive 7. So here, 3 and 4, that's a weird looking 4. 3 times 4 is 12, but 3 plus 4 is 7. So that's going to be my multiplication there. Or number 9, that another time where we have just two terms. That is x squared minus 25. Since that is my difference of two squares, I have x minus 5 times x plus 5. And that's all I have. I'm not going to make you do the rest of those problems. I'm not going to go through those with you because, like I said before, I'm not a fan of this method. It's not my personal preference, but I still wanted to show that to you because what I prefer is not necessarily what everyone prefers. And if this makes sense to you and you want to do it that way because you're a more algebraic person rather than a geometric person and you don't like the X or the box and it makes your paper look all weird, then sure, go for it. You do you. But I'm going to keep doing Xbox factoring because it's what most people prefer. It's what I prefer. It helps me keep organized. So go ahead and do that. Your homework is going to be this worksheet. I have it here available in class. It'll also be posted on Google Classroom for those who are remaining remote. For this, the homework worksheet, you've got these 10 problems on the front side of this that you have to factor out using your GCF, using Xbox factoring, using difference two squares, using other stuff, whatever it might be. So you'll get 10 different answers. They should be unique. There's not going to be any that repeat, but you'll get 10 answers. And then if you flip over to the back side of the page, you've got these answers from whatever this is, 1, 2, 3, 4, 5. So you've got 15 different possibilities for answers. And the way this is going to work is kind of like one of those puzzle times, but one that I made myself, so better, I guess, or at least more unique. So if you think that one of the 10 answers from the front side of the worksheet was 2x minus 1 times x plus 4. So A, you said, was a correct answer. So on this grid, everywhere where there's an A, you're going to shade it in. You can put a little dot. I'm going to go ahead and find all the A's here, and I'm going to say, okay, because I thought that was an answer, probably forgetting some. There's one there. There's another one there. I'm probably missing some, but you get the idea. If you think that G is a correct answer, then you'll go ahead and find all the G's. And you'll go ahead and find some kind of G. There we go. There's a G, and 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 there's a G. If you think whatever the correct answers are, you'll go through and fill out all 10. You'll find all 10 correct answers, which they all are on there. If you get something that's not one of these 15 options, you've made a mistake. Go back and try and figure out where it happened, or let me know, and I'll help you figure it out too. But you'll go through and do this, and it spells something out here, some kind of message for you from me. So that's what your homework is. If you have any questions, either on the notes, on the homework, or you have any other thoughts, ideas, concerns, or questions, obviously make sure you guys are letting me know here in class during office hours from 2 to 2:45, or via email as always. It was nice seeing you guys, and for those of you who are back in person, or if I'm seeing you right now and you're staring at me because you're finishing the video during class and are super confused on what's going on, I see you. Bye, guys.